solve for W. So I'm going to come over here and write the problem or the equation, volume. If I'm solving for W, what that means at the end, W is going to be over here by itself. First of all, I got to figure out what's going on. So I know that since they're so close together, they're being multiplied. I do multiplication with division. And I can do it in one step. I want the W to stay, but I'm going to divide by the L and the H. And what I do to one side, I have to do to the other side. So that means that W is equal to V divided by L times H. And that's number one. Number two. Make that look more like a lowercase. For this one, I'm again trying to get W by itself, and I see that it's here inside my parentheses. So the first thing I can do though is move that 2 to the other side. And since it's being multiplied here, I undo it by dividing. And that leaves me L plus W. And we had, I think, this exact problem on the test. And let me warn you, this is what happened in this next step, and it cost you some points. Okay, remember I'm trying to get W by itself. What do I need to do with the L now? Beautiful. So I'm going to subtract L, and you can show that lots of different ways. So I'm going to show, I can put it underneath, or I can put it right here. I'm going to do minus L on both sides, right? So that takes care of that. This is not where we had where I saw the problem. The problem is when y'all did minus L, you put it in the numerator with the P. That's not correct. The correct is we had the P over 2 and then minus L. Do you see the difference? In the numerator is incorrect because it's saying something different. So just, if you don't care, just be real careful there. Of course, it being multiple choice, I don't guess it would be as much of an issue. For 3, which I'm going to work above number 1, again, you have A is equal to 1/2 times N times A times L, and we're trying to get N by itself. And don't get confused; those are two different variables. We got a capital A and a little a, but those are different. But I'm going to try to get N by itself. First thing I'm going to do is multiply both sides by 2. That makes that 1/2 turn into a 1. So I've got 2A is equal to N times little a times L. Since I want to get N by itself, I'm going to divide both sides by little a times L. So N is equal to 2A to number 4, I'm just going to give you R is equal to I over P times T. And then for 5, the answer is A is equal to C minus B over X. And that'll give you a little bit of practice working those on your own. And if you can't get those numbers to work out correct, or those letters to work out correctly, let me know. I'll be glad to help you. That gives you a little practice. Okay, if we want to look at number 6, this is transformations, and you've got x squared minus 6. It tells you your parents just a plain old quadratic that looks like y equal x squared. That's the parent. It's the simplest one. what has happened here compared to your parent, it's been moved down 6. And all it asked you to do was to sketch the parent function. So, okay, I'm saying the parent looks just like this, except instead of being down 6, the vertex is on the origin. And that's plenty good for a sketch. And we're going to have the opportunity to go the other way. I'll give you a graph and you can give me the example. This is your absolute value graph. And the only difference between it and the parent, it's been moved to the right one. And notice what happens when you move something to the right. Inside your grouping symbols is where that shows up. And if it's right, you do a minus. And if it's left, you do a plus. But if we were going to do the parent, it looks just like this one, but we're looking at the vertexes. So far, so good? Okay, write the equations for the following transformations. Okay, I'm going to read first before I write anything. Absolute value, okay? I'm getting in my mind what that's going to look like. I'm going to move down 5 from the parent and right 3 for the parent. So here's how I'm going to work this. F of x is equal to absolute value. I know what notation I need. And since I've got a horizontal, if you've got a left or right movement, you better have something inside your grouping symbols. And since it moved right 3, I did a minus 3. And then since it shifted down 5, the up and down part acts just like you think it will. So down is minus. Square root, okay? I'm thinking I know square root is going to have to look something like that. I moved down 2, right 3. I'm going to make my square root pretty big because I know there's been a horizontal shift. Right 3 means minus 3, and then down 2. The next one's quadratic. I got to get in my head what a quadratic looks like. I know I'm dealing with some kind of x squared type deal. And the only thing that has happened is there's been a shift left 8. So it's going to be f of x. I'm going to make that pretty big because I know there's been a left or right. And since it moved left, I have to do a plus. And you notice there was no up or down movement, so there was nothing at the end there. The last one also is a quadratic, so I know there's some kind of x squared type deal going on. I look at what's happened to my vertex. You know, on the parent, your vertex is at 0, 0. But now my vertex is at negative 5, negative 2. So what's happened to my transformation? If my vertex is now at negative 5, negative 2, what's happened horizontally? I've moved left 5 and down 2. So the left part goes inside the parentheses, and remember to square it, and then down 2. And based on that, I'm going to give you about 2 minutes to write the equation for 12 and 13. And I'm gonna combine and see how you do on 12 and 13. So take about 2 minutes to do 12 and 13. You're telling me that it moves to the right side. Me too. Well, I got -3. Oh, well, I wrote it down. You're right, you're right, you're right. That's the most of these look really, really good. For 12, and I don't usually make myself a note on the graph. I just, compared to the parent, it moved down 5. So I didn't really have to put anything in parentheses because nothing happened as far as left or right, you know. On this one, compared to the parent, it moved 1, 2, 3, 4, 5 left, and it moved down 1, 2, 3, and it's absolute value, and I just kind of remind myself what that grouping symbol looks like. So 5 left, and then down 3. And most of y'all did great. Write the correct interval, which describes the inequality. We got to think back to the first test. So for this part, I'm not going to show you on all of these, but let me show you how you can kind of sketch these out if you're having a hard time visualizing these. Okay, so x is less than or equal to -10. So I'm going to put a -10 on here. Which way is my arrow going to go now? Beautiful, to the left, and I'm going to do it in blue. Now I've got to make a decision here about open or closed circle. It's closed, which is beautiful because there's this line underneath. Now that I've got a middle picture, I'm going to kind of move over to the left and just describe it left to right. So if I keep going this way, eventually gonna approach. Thank you. Pass that back. I think y'all said this, I hope you said it, and I kind of make myself a note. Negative infinity to negative 10, and if you'll pay attention, just kind of look at the parentheses in the brackets. I don't think we need a picture for this one. Our graph, we're looking at the numbers from 2 to 5, both parentheses, because there's no line under our inequality. And then x is greater than 6. We're starting at 6 and approaching infinity. So, for these next 4, the way I'm going to ask you to determine even, odd, or neither is by putting them in your calculator, and we're going to look at them graphically. So everybody put 2x cubed in your Inspire. If you have your Inspire out, let's practice that. So put in 2x cubed. So, did your 2x cubed look like this?
Yeah.
Okay, and if you're trying to tell graphically, that's why I have them side by side. I just cloned this one. But now, look what happens if I flip this one all the way around. Okay. If I flip it completely all the way around, now compare. They look exactly the same, other than our numbers got turned upside down. So if they look exactly the same when we turn them upside down, what kind of function is that? Odd. Okay, so now go, and if you don't care, put in negative 3x to the 4th minus x squared. And I have it up here for you to look at so you can see if yours matches mine. So what are we thinking? Even, odd, neither. Even is symmetric about the y-axis. I don't know about you, but even's a little bit easier for me to tell. I just can kind of tell even. Okay? Here is, do you have a question? 7x cubed minus 6. Yes, ma'am. Sure. We've got a calculator. So I think probably that's some Now, what, you were making all that your exponent. Now,
He wished for the best of world. Good luck.
I'm glad that happens. When you do that squiggly stuff, it means that you put a bunch of stuff in your exponent. Okay, so what are we thinking about this one? Neither, okay. So if we rotate this
Oh,
one,
wait. No, that's not
and that's kind of what is a clue that they're not going to be odd, because if you rotate this one 100 all the way around, they don't look identical. This one looks like it goes through here, which it does. This one looks like it goes up here in the positive y place.
So
It's neither. You're right. You're absolutely right. Yeah. So it just kind of depends on if you want to how you want to look at it.
we could totally make $100 each one.
Yeah, I think this one is even. The symmetry around the y-axis. See that? So if we look at 21, we've got to talk about increasing, decreasing, and constant. And when I give you an interval, I'm giving you x values, okay? So I gave you -3/2 as an x value and 0. I know when you see two numbers like that, you're thinking, okay, order pair x, y. You're going to have to kind of expand your thinking, because I'm giving you the x value of -1/2, which is what -3/2 is. You see how I went to the x-axis and found -3/2, and then I just dropped the line down to my function? Okay, now I've got to find the x value 0, and I need to connect it to my function. So what they're asking me about is what's happening with this function from this x value to this x value. Is it increasing, decreasing, or constant? Increasing. You got it. Just for some more practice, let's do the next one. I like this one because it's dealing with negative infinity. Well, we know negative infinity is out this way, so I'm just going to kind of line. Now I'm going to find where x is 0, and there's nothing. I know I'm going to have to go up here to find my function, and I want to know what's going on from here to here, and it turns out that it's increasing as well. Now I didn't ask you this, but if and you don't have to write this down, but if I ask you what's happening from 0 to infinity, that one would be decreasing. And I'm going to adjust the graph just a little bit. Pretend this wasn't here, but let's just say right here, it looks like that. That will be a constant from about -2 to 2. Just to kind of give you one of each. Identify the domain. Real quickly, we know what domain, what values we're thinking about when we talk about the domain. Real simply, we're thinking about the x values. So keep that in mind. I'm thinking about the x value. So I've got this function. Its smallest x value is -4. Its largest x value is +1. So that's pretty much my domain. I want to enclose it. So then I just look at my circle.